Hello, everyone. Bruce O here again. This is the second of a two-part video that I recorded as a follow-up to my wheel alignment using a Hunter alignment machine video. Be sure and watch the first part where I address basic alignment angles. If you're not familiar with the three basic alignment angles when it comes to alignments, and also what type of issues you can have from those alignment angles being out. The second part here is basic alignment settings and symptoms. We're going to take a look at some alignment screens off of the Hunter alignment machine, and we're going to look at those settings and see what type of symptoms we think they would cause. Generally speaking, there's some assumptions I'm going with. One is that the vehicles that we're looking at have no other issues causing the symptoms. So we're strictly looking at alignment angles and what kind of issues that would cause. And we would need to recognize that there's several other alignment factors that can affect those symptoms, but we're just mainly speaking of caster, camber, and toe. Vocabulary when it comes to specifications versus settings. Specifications, when I'm talking about specifications, I'm referring to the manufacturer specifications that they send out from the factory in the service manual. When I'm referring to settings, I'm talking about what the vehicle actually reads out, what those angles actually are currently. When we're talking about specification versus adjustment window, a specification, this is the preferred angle or the exact angle the manufacturer says something should be set at. The adjustment window is a range that they give you in that particular setting that you can adjust to address symptoms. Theoretically speaking, if you keep a setting within the range that the manufacturer set up, then the alignment settings will all read in the green. These are alignment rules that I reviewed in my first video. When it comes to front wheel drive, or I'm sorry, when it comes to the front, when it comes to tire wear, the toe being off will give you your most severe tire wear issues. Camber being off will give you moderate tire wear issues. Caster really doesn't play a part in tire wear. When it comes to pulling, the caster is the biggest factor when it comes to pulling. Camber has a moderate effect on pulling. Toe really doesn't cause a pull. Generally speaking, a toe in setting of 1/4 of an inch or 1/2 degree off is likely going to cause concern. And when it comes to camber and caster, a difference from left to right of 1 degree or more will likely cause a pull, caster causing the greater pull. A couple of notes: if the caster is not positive enough, wandering will result. Caster is a factor in the car tracking straight. And generally speaking, front wheel drive specifications will show the tires pointed slightly out when it comes to toe, and rear wheel drive will show the front tires pointed in slightly when it comes to specifications. When it comes to the rear, and we're talking about tire wear, toe has the greatest effect on the rear, camber has a moderate effect, caster really isn't a part of the rear alignment. When it comes to pulling, we're talking about the rear, we call that a push. If the tires are pointed in such a way it's causing the rear to swing to the left, we would call that a push right. So rear non-matching toe will cause a pull. When it comes to pushing or pulling, and we're talking about camber and caster, they really have no effect on a pull. When it comes to the rear, same thing as far as toe, a setting that's 1/4 of an inch off or 1/2 degree off is cause for concern. One note: camber wear on the rear will be slower than camber wear in the front because it doesn't do the turning job. So as we look at these printouts, I'd like to consider 3 symptoms. Will it wear tires? Will it cause a pull or a push in the case of rear wheel drive? And will it cause a crooked steering wheel? We're looking at front wheel drive in this first printout or this first screen. However, we're talking about the rear settings of that front wheel drive car. So we're really not talking about whether or not the steering wheel is going to be crooked. When we look at these settings though, I say that this car is going to have a right rear outside tire wear and it's going to push right. When it comes to tire wear, if we look at toe, the tire is pointed in quite a bit on the right-hand side. That's going to cause wear on the outside of that front tire. When we're looking at camber, since the tire is tilted in, it will be tilted in but pointed in, so that will still cause right rear outside tire wear. And because the rear tires are pointed to the left, then that's going to push the car to the right. The fact that the right rear tire is leaning in can offset some of the tire wear issues. Here's the same Toyota Camry, and the settings are a little different. Take a look at the camber settings. And on this car, I say we won't have a push because the toe is even on the rear, but you should get some slight right rear inside tire wear because of the way that tire is leaning. Looking at this front wheel drive car, take a look at the toe setting. This car, we're likely to get some left rear outside tire wear, and that's because the left rear tire is pointed in quite a bit. And since it doesn't match the right side is not pointed in, that's going to swing the rear of the car to the right, and we call that a push left. Here's a front wheel drive vehicle, and take a look at the caster settings in particular, and the total toe. And this is now we're talking about the front of the vehicle. Okay, on this, all we see is possibly a slight pull left. The toe is even, it's pretty much pointed straight ahead, and that's within the specification. The caster is going to pull to the more negative or less positive side. So if this were a degree difference, we could pretty much guarantee it's going to pull to the left. Since it's only 0.7 degree difference, then that's likely going to pull left. And the fact that the toe is not pointed in or out, it's pretty much straight ahead. I think we're pretty much guaranteed this vehicle is going to pull slightly to the left. Here's front settings on the same Toyota Camry. And now, not only do we have a caster issue, but we have camber to take a look at. Note that almost everything is in the green except for the camber difference from left to right. So you could theoretically put this vehicle on the rack, take a look at everything in the green and say, we're good. But what kind of symptoms would we have here? This car is going to pull hard to the left because it's got a combination of things going on. Number one, the caster being more negative or less positive on the left-hand side is going to cause it a slight pull to the left. But then we're going to add camber, the right front tire leaning in. That's also going to push the car to the left. So the combination of those two things and the fact that the toe is straight ahead is going to cause this vehicle to have a pretty good pull to the left. Next up, same front wheel drive car, cambers back straight again, your casters, more of a difference. This would have a pull left, the caster being more than a degree difference from left to right, and the left side being the lower number, that's going to have a pretty good pull to the left. Same vehicle. Caster's now negative. caster needs to be positive for the vehicle to track straight. When the caster is straight up and down or negative, the vehicle is going to have trouble finding a straight ahead position. So because of the caster being negative, that would cause the vehicle to have an extreme wander, and the fact that it's more negative on the left-hand side, if it does do anything, it's going to pull to the left. Here's front-wheel drive car, and we're looking at a different printout from the machine, and now we're looking at the total vehicle, the front and the rear. So we don't know what specifications are on this screen, but you can accept that if something's in the green, it's within the specification window, and if something's in the red, it's out of specification. So note the toe in the front and the toe in the rear. So considering the rear first, we have the left rear towing in quite a bit on the left-hand side. This is going to cause the rear to swing to the right, which is going to be a push left. And added to that, the toe in the right-hand side is pointed out slightly. So this is going to have a pretty good push to the left. The steering wheel is going to be crooked because those front tires, you have the left tire pointed out and the right tire pointed in, but they're pointed evenly. In other words, the left is out the same amount the right is in. So for the driver to go straight down the road, he's going to turn his wheel straight to where both those numbers are 0. That's going to cause a crooked steering wheel. If this car is pushing to the left, he'll turn to the right even more to fight against that push to the left. So this is going to have a pretty good crooked wheel to the right, and it's going to have a pretty good push to the left. Take a look at this front-wheel drive vehicle. Everything's in the green. But we do know some things about front-wheel drive vehicles. Since the front tires are supposed to be pointed out slightly on a front-wheel drive car, that's because the front tires pulling the car forward will likely pull the tires in straight. We can assume that driving down the road, these tires are going to point in slightly, and that could give you some outside tire wear on the front. Factor in when the car turns and the fact that it's a front-wheel drive and there's more forces against the front tires, that can give you even more outside front tire wear. Here's a rear-wheel drive car that we're looking at the toe setting being off. There's no rear settings. Everything's pretty much straight back there. Since all the numbers are in the white, that's all not adjustable. But on the front, we have our caster angle. Now this is a more positive caster angle than what we've been looking at. But as far as the toe is pretty much straight ahead. So going along with that theory that we need the toe pointed in slightly to fight against the drag that will pull the tires back straight, that's going to cause some inside tire wear. Also, because the this screen is reflecting the fact that the steering wheel is straight. So when we go to this screen, we straighten the steering wheel, and the fact that the tires are both pointing to the left, the driver's going to have to turn the wheel to the, or I'm sorry, both tires are pointing to the right. The driver's going to have to turn the wheel to the left to make the car go straight. So this is going to have a crooked steering wheel going to the left, and it's going to have slight inside tire wear. The last one we're going to look at, I want to just remember all of these settings before we take a look at the next screen. If you need to pause it and take a close look. And let's look at this printout. This is a more complete printout on a vehicle. And has a couple of issues. The rear, the total toe is pointed in quite a bit. And you can see how these numbers play out when it comes to camber, caster, and toe. So this car's going to have a hard pull left. The pull left, we're going to look at caster first when it comes to the pull. And caster has a slightly lower number on the left-hand side. So let's look at camber next as far as a pull. Well, that right front is severely leaning in. So that difference of almost 3 degrees, this camber is going to cause that pull to the left. We're also going to get some front outside tire wear. And the tire wear is going to be on both sides, not just the right front. The right front shows this toe in condition on the right-hand side. But again, the driver's going to have to steer the car to where these numbers come out even. Otherwise, the car won't go straight down the road. So that means both sides are going to be 0.20 pointed in. And that's going to cause outside tire wear on the front. And because he's going to have to turn to get this to steer straight, that's going to cause the crooked steering wheel. It's going to be crooked to the right. That's it for settings and symptoms. I hope that was helpful. Please send me your comments, like the video if you like it, and be happy to have some conversations. Thanks very much.